Dear students, welcome to my channel. Today video we are going to learn about iterative improvement method. This is one of the algorithm design technique. So here we are starting with a feasible solution. Each and every iteration we are finding the better solution. If there is no more optimal solution, we can stop the iteration process. In this iterative improvement method, we are going to learn about Simplex method. So this method is used to solve linear programming problem. So linear programming problem is used to optimize a linear function of several variables that is subject to linear constraint. Let us see one example. So here we are having one function called z. The main problem is to maximize this function 3x plus 5y. So here this function is subject to the constraints x plus y less than or equal to 4 and x plus 3y less than or equal to 6. So here x and y are non-negative variable. The thing is, we have to find the value of x and y that should maximize this function z. At the same time, this condition has to be satisfied by assigning the value to x and y. So for this, we can start with this simplex method by transforming this inequality constraint into equality constraint. For that, we have to introduce the slack variable. So now the equation is transferred into equality constraint by x plus y plus u is equal to 4. Likewise, x plus 3y plus b is equal to 6. So here we are using two slack variable u and b for these two constraints. So if we are having three constraints, we can introduce third slack variable here. So now we can start with the basic feasible solution. We are taking x and y value as 0 and u value is 4 and b value is 6. Then by using the iterative improvement method, we have to try for better solution. So in this basic feasible solution, this x and y are non-basic variables and u and b are basic variables. So to solve the simplex method, we have to start with the initial table, that is a simplex tabla. So here we have to write the coefficient of this constraint. So here in this table, you have to give the value of this variable x, y as well as the slack variable u and b in the column. And in the row, we can use the slack variable u and b. And in the last row, we have to take the objective function. That is our problem is z is equal to 3x plus 5y. So we have to consider this is the objective function. So we have to fill this table by taking the coefficient of these two constraints. That is here x coefficient, y coefficient and u coefficient. So that 1, 1, 1, then there is no v. So we can put 0. Then the right side value 4. Likewise, for the second constraint, we have to take the coefficient of x as 1. Then y is 3. Then there is no u. So that's 0. Then b coefficient is 1 and the rightmost value is 6. So likewise, we have to fill this table. Then the last row is the objective row. So for that, we have to take this objective function. We have to inverse the sign of this function. So here, for 3x, we have to write minus 3. Likewise, for 5y, we have to write minus 5. Just reverse the sign of the variable coefficient. Then we can give 0 for the slack variable u and b. Then the solution is initially 0. So this is our initial table. Now we can start the iterative improvement process. First step is we have to check this objective row. If all the entries are positive, that is the optimal solution, we can stop the process. Otherwise, we have to perform the iterative improvement. So first we have to choose the most negative value in this table. So here this minus 5 is the most negative value. So that this column is considered as the pivot column. That is, this y is the entering variable. So entering variable means we are going to calculate the value of y. That is the most negative entry. Then we have to find the departing row. That is, we have to find the value of this row wise. So we have to replace this departing row value with the entering variable y. So for that, we need to calculate the theta ratio. So the theta ratio can be calculated by using this formula. That is, theta u can be calculated by taking the rightmost value divided by the pivot column entry. So here theta u is equal to this 4 by 1, so that we can get 4. Likewise, theta v can be calculated by taking the rightmost entry, that is 6, divided by the pivot column value 3. So 6 by 3 is equal to 2. So among this 2 is the minimum. So we can consider the departing row is v. So we can mark this one. Okay, so now this is the pivot column, then this is the departing row, and here this value, this 3 is the pivot value. So based on this, we have to formulate the new table. For that, first we have to calculate the row new value. The row new can be calculated by dividing the row value, that is departing row value, by the pivot column entry. So that is 3. So 1 by 3, 3 by 3, 0 by 3, 1 by 3, then 6 by 3. Likewise, you have to calculate the row new value. So we are getting the value 1 by 3, 1, 0, again 1 by 3, then 2. So this is our new row. Then the remaining row, we have to keep this value into the new row. Then for the new table, we have to replace this first row as well as the third row. So the row value can be calculated by using this formula, the row value minus the pivot column entry into the row new value. So let us see how to calculate the first row value. So the row 1 value minus the pivot entry is 1 into the row new value. So 1, 1, 1, 0, 4, then minus this pivot value 1 into the row new value, this one, 1 by 3, 1, 0, 1 by 3, 2. So by subtracting this one, we are getting the value 2 by 3, 0, 1, minus 1 by 3, then 2. We can replace it into the row 1 of the new table. Likewise, we have to calculate the third row. So row 3 value minus the pivot column entry is minus 5 into the row new value, this one. So for this, we can calculate like this. The row 3 value is minus 3, minus 5, 0, 0, 0. Then minus 5 into the row new value 1 by 3, 1, 0, 1 by 3, 2. So that we are getting the value like this, minus 5 by 3, minus 5, 0, minus 5 by 3, minus 10. So subtracting this values, we can get the value like this, minus 4 by 3, 0, 0, 5 by 3 and 0. This is our new table. Now we have to check the objective row entry. Here still some negative values are there, so that we have to repeat the process. So this is the negative column. So we can choose this is the pivot column. So that X is the entering variable. Now we have to choose the departing row. So in the previous table, the V value is replaced with this Y. So now we have to calculate the theta value. So theta U can be calculated by the rightmost entry 2 by this pivot column entry 2 by 3. So we are getting the value 3. Likewise, next row can be calculated by the last entry 2 divided by this 1 by 3. So we are getting 6. So here this one is the minimum value. So this is the departing row value. So now we can mark this one. So this is our pivot value. 2 by 3 is our pivot value now. So now we have to calculate the row new for this row. So here pivot value is 2 by 3. So this row entry should be divided by this 2 by 3. So first value 2 by 3 by 2 by 3, then 0, again 1 by 2 by 3, then minus 1 by 3 by 2 by 3, then 2 by 2 by 3. So after calculating this, we are getting the row new value as 1, 0, then 3 by 2, then minus 1 by 2, then this 3. Now we have to calculate the remaining 2 rows. So row 2 can be calculated by taking the values of this row minus the pivot column entry 1 by 3 into the row new value. So multiply this 1 by 3 with these values, we are getting the value like this. So subtract the value 1 by 3, 1, 0, 1 by 3, 2, minus 1 by 3, 0, 1 by 2, minus 1 by 6, 1. So after subtracting this, we are getting the second row value like this: 0, 1, minus 1 by 2, then 1 by 2, then 2 minus 1, 1. Then the third row can be calculated by taking the third row value minus 4 by 3, 0, 0, 5 by 3, 10, minus the corresponding pivot column entry is minus 4 by 3 into the row new value. So first multiply this pivot column entry with the values, then we can subtract it. So after subtraction, we are getting the value like this. So minus 4 by 3 minus 4 by 3. So we can get the value 0. Then the second value is 0. Then 0 minus 2. So we are getting 2. Then 5 by 3 minus 2 by 3. We are getting 3 by 3. So that we are getting 1. Then 10 minus 4. So 14. So this is a third row value. So now we can form the new table with these new values. So now in the first row we are having the value x. So that is x value is 3. Then the second row we are having the value for y. Y value is 1. And the last row we are getting the value 14. So this is our final solution. That is, now we are checking the last row value. There is no negative entry. So this is our optimal solution. And we are taking the value of x as 3 and y as 1. And if you are placing this value in our objective function z, we are getting the value 14. So 14 is our optimal solution. So in this iterative improvement method, once you reach the last step, that is there is no negative entry, we can stop the process. We are stopping the iterative improvement process and we are getting the optimal solution. So in this way, we can find the solution of the simplex method.